this is that. Today we are now going to do question 3 of 2012. Today we now have a cubic. Now, what's a cubic? A cubic is a polynomial on degree 3. Cubics can have 2, 1, or no turning points. Actually, cubic's one turning point isn't really a turning point. It's actually what's called a point of inflection. So anyways, find a condition such that the curve has 2 distinct turning points. So this means we need to find a quadratic where it has b squared minus 4ac is less than 0. So this means we need to find f prime. F prime x equals to 3x squared plus 2ax plus b. So that means b squared minus 4ac greater than 0. 4a squared minus 4 3b greater than 0. So this means a squared minus 3b is greater than 0. So let x1, x2 denote the x coordinates of a and b respectively. Show that x2 minus x1 is this. So this means we will need the square root of the discriminant, let's call it d, over a. And this a is 3. So this means this is a squared minus 3b. It's actually 2a squared minus 3b because square root of 4 is 2, so we can put 2 in front and then 3. There, we proved it. Suppose now the graph of y x is translated to the turning point of a now lies at the origin. Great. So the distance is 2 to a squared minus 3b. So this cubic will have a repeated root at 0 and a root at t. So this means gx equals to x squared x minus t. So this means g prime x equals to 3x squared minus 2tx. And if we look up here, so g prime x is 0. So this means equals to x 3x minus 2t. So this means 3x minus 2t equals to 2 square root of a squared minus 3b over 3. And the x actually turns out to be square root of a squared minus 3b. So this means t equals to 2/3. Let's write this down quickly. So this means that g of x, wait a sec, is actually, t, sorry, I had a small typo here. T is actually the square root of a squared minus 3b. So let's quickly write that down. So g of x is x squared, x minus square root of a squared minus 3b. There. So let R be the area of the region enclosed by the x-axis. So that if A and B are rational, then R is also rational. So this means square root of a squared minus 3b, 0, x squared, x minus square root of a squared minus 3b dx equals to 1/4 x4 minus a squared minus 3b over 2x cubed. So this means it is a squared minus 3b squared 1/4 minus half. So this means this area is negative. So this means R equals to the modulus, so a squared minus 3b squared over 4. So since the squaring operation and the subtracting linear combination operation are in the field Q, as it's called, is the field of the rationals, then if A is rational and if A and B are rational, then big R is rational. And now the final question. Is it possible for R to be a non-zero rational number when A and B are both irrational? Yes. Let's say A equals to twice the 4th root of 2 and B is the square root of 2. So this means R, let me calculate this R will be half. There, we have done the question. See you.